Welcome. I have my friend Jake here, and Jake, why don't you tell him what we'll be going over?
Today we will be going over the different topics in Unit 5.
Yep. So we have 7 different questions, 6 of which that were given to us, and 1 that we made on our own. So I say we get ready for 7 innings of some math problems.
So here's our base equation, integral of negative 5x minus 1 d of x. So first what you want to do is take this negative exponent and move it to the bottom, making the equation integral of negative 5 over x d of x. And then from there, you can move the negative 5 to the front of the equation, making the new equation negative 5 integral 1 over x d of x. Now this equation sets up for us to be able to transfer the equation into the natural log equation. So it'll then become integral 1 over u du would then become natural log of u plus c. So if you plug these numbers into the new equation, it'll become negative 5 natural log of x plus c, and that is the answer.
Welcome to the ballpark. I think we should do number 2 next. All right. Now we have the integral of negative 2 over x times dx, which is kind of a similar problem to our last one. So from here, we have to bring out the negative 2 in front of the integral. That would be the next step in solving the problem. So we have negative 2 integral 1 over x times dx. From there, we can solve our problem. There's not many steps we need to solve this. And we know the formula from the last problem. So from here, we're able to just write out negative 2 times the natural log of, oh wait, sorry, let me erase this. I messed up a little bit. Negative 2 natural log times x plus c. And that's a home run in my books. And that will be number 2. And now Jake will demonstrate number 3.
Howdy folks, I'm Jake Gita and I'm coming at you with number 3. So the base equation is the integral of negative 4 times 2 to the power of x d of x. And our goal here is to fit this equation into this formula so that we can further simplify the integral. So our first step is going to be to move this negative 4 to the front of the integral. So we're going to go negative 4 integral 2 to the power of x dx. And this fits the formula up here now. So we can further simplify by going negative 4, and then you want to take the integral out because it's no longer in the equation once you simplify it. So you want to go negative 4 times 1 over ln, and your a value is 2. So that replaces the a. And then times a, which is again 2, to the power of x plus c. And now to further simplify, you can multiply these 2 terms together and get negative 4 over ln 2 times 2 to the power of x plus c.
Hello. Now we are going to do number 4, which means we got bases loaded since we did the other 3. All right. Now for number 4, our question is 24x over 4x squared minus 5 all times dx. All right. So the next step from here is to find our u. All right, so our u would be the bottom here. So it would be 4 x squared minus 5. All right, now that we have our u, we have to find out our du over dx, which is basically just the derivative of this, which we have learned in previous units. So we can figure that out easy. So du over dx would equal just 8x, because you would multiply the 2 to the 4, and then you take away one of the exponents, you minus 1 to the exponent. So that just leaves us 8x, and then if there's no x, then it just goes away. All right, so now for our next step, we find dx. So our dx is equal to du over 8x. All right, now that we have all of this figured out, we have all of it laid out for us. So our next step would be, write it out here, for x over u times du over 8x. All right, and from here we are able to, oh wait, sorry, I wrote the integral wrong. We put it in front of the whole thing. From here, you are able to simplify our 24x and our 8x. So that would leave us with just 3 over u times du. Okay? And from here, it would just be integral of 3 over u du. All right, and then from here, we've done in previous problems, we take the 3 in front of the integral, so that leaves us with 3 integral 1 over u du. Okay, and after we have all that figured out, we can put it into the formula that we have used on previous problems, and then that will give us 3ln times u plus c. And then the last step would obviously, why we did this to begin with, we just plug in u. Plug in the starters, as Mr. Kim would say. It would just be 3ln times 4x squared minus 5 plus c. All right, and that would be our final answer for that. And now on deck is Jake Ida for number 5.
Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jacks. I don't care if I ever go back, 'cause it's root for the Braves and Bears. If they don't win, it's a shame. Oh, there's a ball.
I got it. I'm Jake Ida, and I'm back with question number 5. So, our question is 100x to the power of 3 over 5x4 minus 4 dx. So our first step here is going to be to figure out how to determine the u. And because the denominator has the highest exponent, that's going to be our u. So u is equal to 5x to the power of 4 minus 4. And then our next step is going to be finding the derivative of u. So du over dx is equal to, and to find the derivative, you multiply the coefficient by the exponent and then subtract the exponent minus 1. So it's going to be 20x3, and then that's just going to be 0 since it doesn't have an exponent. And then once you find the du over dx, you then have to find the d of x. So we're going to multiply both sides by d of x, and get du is equal to 20x to the power of 3 dx, and then to get d of x, divide both sides by 20x to the power of 3. So your dx is going to equal du over 20x to the power of 3. And now that we got these values, we need to plug them back into our original equation. So we'll have the integral of 100x to the power of 3 over u times du over 20x to the power of 3. Just divide it there. And so our first step here is to just simplify. So these x to the power of 3's will cancel out, and the 100 and the 20 will simplify out to 5 and 1. So we'll have the integral of 5 over u times d of u. And now, to further simplify the equation, you want to move the 5 out from the numerator and move it in front of the integral. So we're going to get 5 integral 1 over u times du. And now this equation fits our integral formula. So using that formula, we're going to get 5 ln u plus c. And then you have to sub in the u back to the starters. And that's just going to turn the u into 5x to the power of 4 minus 4. So 5x to the power of 4 minus 4 plus c.
All right, now we're back here for number 6 after my good old friend Mr. Jake Gita did number 5. All right, for number 6, it was a little bit of a different question, so we decided to change the scenery. So for number 6, we have an integral with a limit on it. So it's 3 to 2, and it's -2 over x minus 1 times dx. Okay, so our first step would be to just find the u, which is equal to x minus 1, because that's what was in the denominator that had the highest power. And then from there, we had to take the derivative of u. So du over dx equals 1, because x, or the derivative of x is just 1, and then the derivative of -1 is nothing. It erases it. So then that obviously leaves us with dx equals du. So they're interchangeable. All right, next, we're gonna start carrying out the problem again. We have the integral of -2 over u times du. And then from there, we take out the -2, put it in front of the integral, and that leaves us with -2 integral 1 over u times du. Okay, and from there, we used our handy dandy formula up here in the corner. It's FAB equals capital F times A minus capital F times B. All right, so then we bring that down here. Our F with the A subbed in would be -2 natural log times x minus 1. And our F of B would be the same thing. And then, so after we substituted the values into the problem, that gave us -2 natural log times 3 minus 1 minus -2 natural log 2 minus 1. And after that, after doing what was inside of the values here, we have -2 natural log times 2 plus 2 natural log times 1. And after that, our final answer was -1.386. And that is all for the problems we were assigned. Now we are going to make a new problem so we can knock it out of the park. Okay. After we've completed all the other 6 problems that we were assigned, for the last one we got to make up our own. So me and Jake decided for the last one we would do integral of 1 over 2x plus 5 times dx. Okay, from there we have to find our u, which equals 2x plus 5 because it's a denominator, and we chose that because it has the highest power. From there, we took the derivative of u, which is du of dx, or du over dx equals 2, because the derivative of this right here would be 2 because this changes to 2 and then this disappears. From there, we can say that 2 dx equals du, and also dx equals du over 2. And now Jake will do the second part of the problem after I did the setup stuff. Jake will now carry out the rest of it.
So once you get your u and dx values, you can then plug it into the original equation. So you'll get the integral of 1 over u times du over 2. And then to further simplify, what you need to do is take this 2 out so it can fit the integral equation. So you bring it out in front of the integral and get 1 over 2 integral of 1 over u times du, and then that fits the integral equation. So you can then make it 1 over 2 natural log of u plus c, and then you sub back in the original u value, so it ends up being 1 over 2 natural log of 2x plus 5 plus c.
And I think we did such a good job that I think we could even just go find our star third baseman on the Cambridge varsity team, and even I think he can understand it after watching our videos.
After watching Jake and Jack's video, I think I could use this in my math class to pad my grades, just like I try to pad my stats on the baseball field.
And thank you for coming out. Me and Jake just went over 7 problems, and I hope you come back out to the ballpark soon. Thank you again, and have a good rest of your day, folks.